Now I will cover some of the important questions related to chapter 8 that will must come in the exam, and the usually student do some common mistakes in such questions. Let's see now one by one each question. First question, which changes increase the rate of reaction? So the rate of reaction, there are four factors that can increase the rate of reaction. First is the temperature, the second is the pressure, third is the concentration, okay, and fourth is the catalyst. These are the four factors that can increase the rate of reaction. In concentration, you can have two types. Either it can be a surface area, okay, a high surface area for the solid, okay, and for concentration for the liquids, okay. So surface area, if it is higher, then the rate of reaction will also increase. So higher the temperature, higher will be the rate of reaction. Higher the pressure, higher the rate of reaction. High, if you add the catalyst, higher will be the rate of reaction. Higher the concentration, the rate of reaction will be higher. So surface area also higher, then it means the rate of the reaction will increase. So now let's see one by one. Increasing the concentration of the reactants. Yes, that option is right. Increasing the particle size of the solid reactant. What does it mean? If you are increasing the particle size is inversely proportional to the surface area. If you are increasing the size, it means you are decreasing the surface area. So it means if you decrease the surface area, the rate of reaction will also decrease. So this option is not right. Increasing the temperature, yes, right. So option 1 and 3 are only the right option, that is C. Let's see another one. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Why does magnesium powder react faster than magnesium ribbon? So if you see what they are asking about magnesium, and magnesium is a solid, right? So for solid, actually the surface area matters. Higher the surface area, higher will be the reaction rate, okay? So if you see, why does magnesium powder? Because magnesium powder has a higher surface area. That's why the rate of the reaction will be higher, right? So why the rate of the reaction will be higher if there is a large surface area? It means more particles will be exposed, okay? There will be more particles that will be exposed to other reactant for the reaction. So you see, now we can see the option. The magnesium atoms in the powder have nothing to do with the low activation energy. The powder have a smaller surface area, again wrong, because the powder has the larger surface area. That's why the reaction has a higher rate of reaction. The magnesium atoms in the powder have more frequent collision with the acid particles. Yes, this option is right. Now they have more particle collision because now they are more exposed to the acid. The acid is another reactant, right? So because you have increased the surface area, so when the surface area is increased, it means now there are more chances of collision with the other reactant. So option C is the right option for this question, okay? So if you are increasing the concentration or increasing the surface area, the reason behind increase of the rate of reaction is actually the more number of collision. More number of collision will actually result in higher rate of reaction in terms of concentration, in terms of increasing the surface area, and also in terms of increasing the pressure, okay? But for temperature and catalyst, the reason is different. We will see that. So option C is the right option. Let's see this one. Which change in condition increase the energy of the particles in a reaction? Okay, so which change in conditions can increase the energy of the particles? Now they are not asking about the rate of reaction. They are asking about the energy of the particles. Which factor is actually increasing the energy of the particles? Let's see one by one. Addition of a catalyst has nothing to do with the particle. It is always used to decrease the activation energy of the reaction, not the particles. Activation energy of the reactants, okay? That's why we add cat. Increase in concentration. Increasing the concentration, I already have told you, increasing the concentration, increasing the surface area always increase the rate of collision, okay? Why increase the rate of collision? Because more particles are now exposed to each other. So energy has nothing to do with concentration, with surface area, and also with the pressure, okay? Now the only thing that remain is temperature. Temperature, actually, when you increase the temperature, the kinetic energy of the particles increase increase. So kinetic energy is actually the particle's movement energy. So that's why increasing in temperature is the right answer. That changing the factor, that is temperature, will increase the energy of the particles, and now the particles will collide more successfully with each other and more frequently. So option D is the right option. Whenever you see the word energy, only temperature is responsible for increasing the energy of the particles. Okay, no other factor is responsible. Weight change increase the rate of reaction by decreasing the activation energy. So now they are asking about activation energy. They are not asking about the simple energy or the kinetic energy. So activation energy is always decreased by adding a catalyst. Activation energy is not the energy of the particles, it is actually the energy of the reaction system. Okay, so the reaction system has now lower activation energy because of adding a catalyst. So addition of a catalyst is the right option. See the word activation energy. Decreasing activation energy is only we can get through the addition of a cat. Okay, so you have to just choose the option of addition of a catalyst, that is option A. That is the right option. Now let's see another question and how you can measure the rate of the reaction. The rate of reaction means how quickly a reaction is taking place, and how quickly means what is the time. The time is important. You have to measure the time actually, that how much time a reaction is taking to finish. Okay, so how you can measure the rate of reaction? Either you can just measure that how much time it has taken to make a new product, or how much time it has taken to absorb or to consume all the reactants. So there are two options. You can either measure the reactants that are consumed, or you can measure how much time has taken to make a new product. Okay, it depends on the situation. So now let's see, they are asking you that which two diagrams show suitable method for investigating the speed of the reaction. So now, for example, in one, what is the reaction? A liquid X react with solid Y to form a gas. Now your product is a gas, right? So if you want to measure a gas, because they are trying to measure a gas here, the product, so your whole apparatus should be according to that rate of reaction, okay, that you are measuring. So now you are measuring a product that is a gas, so your apparatus should also be the same one. Here we are measuring a gas, right? But there, if you see, when you are measuring a gas, everything should be close, so all the measurements should be right. If you see, when the gas will be formed, what will happen? Some of the gas will evaporate over here, right? When it will evaporate, you cannot get the right volume of your product. So it means this apparatus is wrong. You cannot measure the exact volume of your product at a specific time because they have not used a cork here. Okay. Now let's see a second option here. Which option is right? Now they want to measure how much of your reactant has been consumed. Why? Because if you see, they are not measuring the gas, they are actually using a balance, and they want to measure that, okay, in start it was 42 the reactant, now what is the mass at the end of the reaction? What will be the mass? So they want to measure the mass. So for that purpose, they have to add just a cotton wool so that all the gas can evaporate. Once the gas is evaporated, your product has been removed. So now you can see the change in the mass. So once you see the change in the mass, it means you can measure the rate of reaction. So this option is the right option. See another one. Now these two look same, but they always have used a cork, or you can say a stopper. So now the gas will not move out. So the balance will not any weight. Okay, you cannot see any change in the weight because the product, the reactants, everything is in this beaker now. So how you will know that the reaction has been finished or it has been completed? Because the product is not going out, right? So this option is wrong. Why? Because they have used the stopper. Now let's see this option 4. In option 4, again, they are measuring the product. Now they are not looking at the reactant like in the option 2. So now when they are measuring the product that is a gas, so what are they doing? They are using a stopper. So all the gas just move into this syringe and it don't move out. So it means this is the best technique that you can measure your product. So option 2 or option 4, they both are right to measure the rate of reaction. So that's why option D is the right option here. Let's see another question that is related to the graph. An experiment is carried out for the rate of reaction between HCl and zinc. The result of experiments are shown. What is the label on the y-axis? Okay, remember that I already told you that rate of reaction you can measure either by measuring how many reactants have been consumed per unit time, or how much product is formed per unit time. So now you have two choices. Either you can measure the reactants consumed or the product formed, right? So if you are measuring the product formed, then your graph will always start from zero to the towards the top, okay? If it is like this, and for reactant it is always from the top to the bottom, because at the top you have more reactants and slowly they have been consumed. So if the graph is like this, it means they are talking about the reactant. They are actually measuring the reactants now. So can you see in this graph, it is coming from the top towards the bottom. So it means the option can be zinc or HCl. What is the label on the y-axis? It can be either zinc or HCl. Okay. So what is the label on the y-axis? The amount of zinc chloride, of course, wrong option because it's a product, and H2 again wrong. So now we are only left with two options: concentration of HCl and mass of zinc react. So if you see, if they say that mass of zinc is reacted, it means they are not talking about what is left behind. They are talking about what has been consumed, right? So the graph will be from top to the bottom. In start, the consume was less and now it is increasing, right? So the graph should be like this, but now the graph is from top to the bottom, how much it is consumed. So it means the concentration of HCl is the right option here. Why? Because once we have more HCl in start, and slowly the concentration will decrease because this HCl will be consumed. So that's why option B is the right option. See another option now. 64, hydrochloric acid is added to excess calcium carbonate. Don't forget the excess is a very important information, okay? So this one will actually decide your answer. And also you have to look at the graph now. In two different experiments, two different concentration of HCl are used, okay? But the temperature is the same in both experiments. The graph of the results show the volume of carbon dioxide given off over time. So if you see both the graphs, first and second, in one they have used less concentration, in the second they have used more concentration, right? And if you see the volume of the gas is also very high, right? Different, it's not the same. So it means the reaction is not only affecting the rate of reaction, but it's also affecting the product number. It is also affecting the product volume. What does it means now? The collision rate is higher. We have to see which row. Particles in 2 mole dm cube compared to 1 mole cube. Now we have to look for the answers for 2 mole dm cube. Okay. So what is happening to the particles in 2 mole dm cube? The collision rate is higher or lower? Of course it is higher because the graph is more steep, right? You are getting more volume of the carbon dioxide and in a smaller time. In small time, like in this much, 1 minute maybe, for example, you are just getting this much steep. But here it is more steeper, right? So it means 2 mole of the 2 mole per dm cube concentration has higher collision rate. So option A or B can be right. Now the second option is about collision energy. The energy of the particles with which they are colliding with each other. Is it more or less? It only depends, I already told you, on temperature. Okay, so temperature is the main reason behind the collision energy. So if you see, the temperature is the same. They have not changed the temperature. So it means the collision energy was not changed. So option A is the right option. Okay, so that's why you have to choose option A. Let's see question 65. An excess of calcium carbonate reacts with dilute HCl. The volume of carbon dioxide produced is measured at regular time intervals. The results are shown in experiment 1. The experiment is repeated with only one change to the reaction condition. Okay, and we have excess of calcium carbonate here, right? And we are reacting with dilute HCl. So now if you see which change is made in experiment 2, if you see experiment 2 is more steeper, what does it mean? It means anything you have added is actually increased. You have increased something, that's why the graph is more steeper than experiment 1. It means the rate of reaction is higher in experiment 2, right, than experiment 1. So it means something has been increased in experiment 2. First, the concentration of the acid is increased. If you increase the concentration of an acid, what will happen? of course the experiment 2 will have higher rate of reaction, right? So we can choose this option also as an option. Let's see now, the volume of the acid is increased. This option can also be right. Okay, the mass of calcium carbonate is increased. This option Y is not right because they already said that excess of calcium carbonate is there. So even if you increase, nothing will change. So excess of calcium carbonate means it cannot be the option because we already have a lot of calcium carbonate. So only thing that is responsible can be either concentration or the volume. The calcium carbonate is powdered. Even if it is powdered, you will see an increase in the rate of reaction, right? So that can also be the option. Now the main thing that will help you to choose the right answer is that these factors actually increase the rate of reaction, right? But if you see over here, these two lines, they are not giving you the same number of the product. The product volume is also different. If the graph was like this, then option A or D could have been right. At the end, the product size should be equal. But here, if you see, the product size is also not equal. The rate of reaction is also higher and the product size is also higher. So it means the only option that can be right here is the volume, because they increase the volume. So now the concentration is also increased and the volume, the number of the particles also increase. So more chances of collision and also there are more number of particles to collide. So that's why you have more volume of carbon dioxide. So the best option should be here is B. It should not be concentration, because if you are choosing concentration, it means that rate of reaction has been increased, but there is no difference in the volume. But if you see, there is also a difference in the volume. The product is not the same in experiment 1 and 2. So the option you can choose is volume, okay? Because more will be the number of volume, it means the concentration has also been improved and also now the volume is also improved. So now your rate of reaction will also be more and also your product size will also be bigger. That is the volume of carbon dioxide. So that's why option B is the right. Let's see 66. The zinc granules are reacted with the excess dilute HCl. The volume of hydrogen given off is measured at different times. The results are shown on graph labeled 1. The result of second experiments are also shown on the graph labeled experiment 2. So excess dilute. So we have dilute HCl is in the excess amount, okay? So which change to the condition was made in experiment? If you see, the experiment 2 is less steeper than experiment 1. It means something has been decreased here now, because this one is slower. The rate of the reaction is slower, but the product is same, right? So it means nothing to do with the volume. Now the factors can be temperature, pressure, or concentration or surface area. We can see one by one. The concentration of HCl was decreased. Okay. The second is the size of the zinc granules was decreased. If you decrease the size, the surface area will increase. So if you increase the surface area, the rate of reaction will also increase. But here the rate of reaction has been decreased in experiment 2. So that means this option is wrong. The surface area of the zinc granules was increased. Again wrong, because if you increase the surface area, the experiment 2 will have higher rate of reaction. But here if you see, it is less steep than experiment 1, so the rate of reaction is lower. The temperature was increased. Again wrong, because if temperature was increased, the rate of reaction should also increase and experiment should be here, not at the bottom, right? So it means only option A is the right option. The concentration of HCl was decreased. So when there was a decrease in the concentration, the rate of the reaction also decreased, right? But there was no effect on the volume. I hope this point is clear to you, because the concentration actually is responsible for the rate of the reaction, not related to the product size, that how much product you are going to get. It's usually depend on the volume. Okay, if you increase the volume, then you will also get the more product. So option A is the right option. Question 67. Student add excess magnesium rubber to 10 centimeter cube of 0.45 mole of the sulfuric acid. The hydrogen gas produced is collected and its total volume is measured every 10 seconds. The experiment is repeated with 5 centimeter cube of 0.5 mole DM cube sulfuric acid added to 5 centimeter cube of the water using the same mass of magnesium ribbon. Which line of the graph shows the result of second experiment? So there are so many information given to you already. So what you can do is first you can find the mole. How many moles of this one are used? If you see magnesium ribbon is 10 centimeter cube and the moles is 0.5. This is the concentration. So how many moles are you have used? The 10 can be converted into dm cube. So 0.001, right, into 0.5. I hope this is clear to you. So now the answer will be how much? 0.001 into 0.5. You will get how much the volume is 0.0005 moles. Okay. First time you use this one. Then the experiment is repeated again with 5 centimeter cube of 0.5 mole of the dm cube. So how much is this one now? 5 means it is 0.00. Okay, this one was, wait a minute, 10 into 1000 is 0.01. Okay, this is 0.01. So if you get it here, 0.01 into 0.5, you will get 0.00. Now here we have 0.05, and then when you multiply with 0.5, what you are going to get? 0.005 into 0.5. You are going to get 0.005. Okay, but if you see the same volume has changed 5 centimeter cube and then you added 5 centimeter cube of more water. So what does it means? It means you have added again 0.5 of the water. The volume has added again. So now what will be the moles? 0.005 again. So it means you have same number of the volume. If you see, the volume number is same. But what is the difference now here? The moles are still 0.0025. So the moles of the second experiment are less as compared to the first experiment. Okay. If you guys are getting confused, I will explain it again. If you see here, just look at the information. The first experiment volume is 10 centimeter, right? The first experiment has 10 centimeter cube as a volume. But the concentration is 0.5 mole. In the second one, the second experiment, you have 5 centimeter cube of volume with the same concentration, that is 0.5 mole, right? But the water is added again. So when the water was added again, the concentration become how much? 0.25. So now the concentration is 0.25, but the volume is same, right? So now the volume is same, but concentration is different. So what will be your answer? Most probably your answer, if you find the number of moles here, what will be the number of moles for first experiment and second experiment? If the number of moles will be less, it means your product will also be less. First experiment will have how much moles? It will be 0. How much? 0.01 into 0.5. So what will be your number of moles? 0.01 into 0.5, you will get 0.005. These are the number of moles for experiment 1. But for experiment 2, if you see the number of the volume is same, 0.01, but concentration is 0.25, right? So for 0.25 into 0.01, the number of moles will be 0.00. So it means now the volume of your product will also be different. It should not be same, okay? The rate of the reaction will also be different, and also the volume will also be different. So these three lines cannot meet each other at the same point. What does it mean? It means you will not get the same number of the product. So it means either this option or this option is right towards the original experiment, okay? This is the dotted line is our original experiment. Now if you see which line of the graph shows the second experiment, if you see the second experiment has lower number of moles compared to first experiment, it means your product will be less. So option D can only be the right option because the product size is also smaller. The rate of reaction is also less because the graph is not so steep. So option D is the right option. I hope this point is clear to you. You have to find the number of mole to check that which one will produce more product. Okay, let's see another example of question 68. An excess of calcium carbonate is added to dilute HCl. So now we have excess of calcium carbonate. The carbon dioxide gas is given off and calculated. Its volume recorded at regular time intervals. The line X on the graph shows the result obtained. Okay, the experiment is repeated again using dilute HCl. Line Y on the graph shows the result obtained. Okay, and they both have the same volume, right? It means that only the rate of the reaction has changed. There was no effect on the volume. So now let's see what is the difference. They had the same volume, yes, okay, but the Y had a higher concentration. Is this right or not? If they have the same volume, because they both are dilute, okay, so if they both are dilute, then the volume should be, if the concentration should be higher for Y, right? The Y has a higher concentration. But if the volume is same, then they cannot have the same product size. The product size should be different, right? But here, if they have the volume should also be different. So now let's see, they had the same concentration, but Y had a larger volume. Again, wrong. If Y had a larger volume, the product size will not be the same. Only the rate of the reaction will increase. Okay, so this option is also rejected. Now let's see, X has a higher concentration. Wrong. Why wrong? Because it is less steep, so we cannot read this. Y had a higher concentration. Yes, that's right. Y had a higher concentration. That's why it is, you can see that the speed of the reaction is faster, right? So Y has a higher concentration, but X had a larger volume. Now this option is Y, right? Because if X don't have a larger volume, then the product should also be different. But here the product is same, right? So it means that X is compensating with Y through its volume. It has large volume, but Y has higher concentration. So higher concentration increase the rate of the reaction, but the volume is actually, the X has a higher volume, but it is more dilute. So that's why the products are same, but only the rate of reaction is lower. So that's why option D is the only right option over here. Let's see now another example. Powder magnesium carbonate is added to excess dilute HCl. The total volume of the gas is produced over time. The graph of the line is shown here, right? The experiment is repeated, but the concentration of the hydrochloric acid is doubled. All other conditions are kept the same. Which statement about the second experiment are correct? Now let's see again, the HCl concentration is double. What does it mean? The rate of the reaction will be increased. Okay, so if you see what is the time taken by this reaction, it's 75 or maybe 90 right here. So the reaction finished before 90 seconds. Yes, the rate of the reaction will be higher because the concentration is higher. The activation energy of the reaction is lower. That is wrong, because concentration has nothing to do with the activation energy. Only a catalyst is responsible for lowering the activation energy of the reactant. So I hope these 2 points are clear. Now let's see the first option. The final volume of a gas is 360. How much is the final volume, total volume of a gas we have over here? We have just here around maybe less than 200, right? Okay, so they already have told you that the experiment was repeated, but all other things were remain the same. All other conditions were kept the same. It means they have not changed anything. They have not increased the volume. They have not increased the temperature. Nothing was increased. Okay, so the final volume of a gas cannot be increased. Okay, so that's why it should not be 360 centimeter cube. That is the wrong option. Why wrong? Because we already have powder, we have just powder magnesium carbonate. And even if it is highly concentrated, you can think that, okay, the concentration is more and we have more number of particles, so the product can be more. But the problem is that your other reactant is in excess amount. It is just simply the powder magnesium carbonate. They have not used the word excess with magnesium carbonate. If magnesium carbonate was excess and the concentration of the HCl was increased, then you can get more volume. But now here you will get the same volume because we don't have more magnesium carbonate. Okay, so that's why option 1 is also not a right option. So only right option is 2. So option D is the right option. Let's see another question that is related to the rate of the reaction and how in a graph you can find that at which time the rate of reaction is the fastest. For example, this question, magnesium is reacted with dilute HCl, the hydrogen gas is collected and its volume is measured. The results are shown in the graph between which time the reaction was fastest. So simply, if you are getting confused, you don't know how to find 0 to 1 minute, you can just try to draw the triangle. Okay, so you can see your triangle is this much. The size is only this much. Now let's see for 1 to 2 minutes. So this is the ending point of 1, so you can draw it from 1 to 2. So now you see this is a little bigger, so this one is bigger. Now for 2 to 3 minutes, so your 2 is ending at this point, so you can draw again the line over here, and you can see this is your 3, this is 4, so this line is like this, right, more bigger. Now from 7 and 8, this is 7 and this is 8, so if you see this line is straight, so this is the tallest line. It means this from point 2 to 3, it was the reaction was the fastest reaction. That's why option C is the right option. I hope this point is clear to you, that how you can find the speed of the reaction. You can just try to draw the triangles. The triangle that has the longest straight line, it has the longest 90-degree angle. It means that triangle, actually that point is that time is actually the time where the rate of the reaction was the fast. Now see another one. The volume of a gas given off in a chemical reaction and it is measured over time. The results are shown at which time the rate of the reaction is the fast. At 0, you see it is just a straight line. At 4 seconds, if you see, we can just measure from here 2 to 4. So the line is this much, right? And from 4 seconds to 6 seconds, if you see here for 6 seconds, the line will start from here and it will move up till, you can see here, this is your 6. So where it is moving, this, can you see this line? This line is the tallest line over here. But let's see for 10 seconds. So for 10 seconds, if you see the 8 is here, right? Okay. So from 8 to 10, it is just a very small line. The 90-degree angle is very small. So it means the degree angle of this one, 6 seconds, is the highest or it is the greatest. So that's why option C is the right option. The rate of reaction at 6 seconds was the highest one.